Okay, guys? So we're going to do a lesson that allows us to see why these things are happening, right? This is such an important part of algebra that I want to spend a little more time talking about the why those shortcuts work and why you need to use them. And then we're going to practice using them some more, okay? So, laws of indices. So remember, we've seen that if you multiply an m to the third times an m to the fourth, we get m to the second. And again, what we're going to do today is just kind of remember why. When you divide an a to the fifth divided by a to the third, you get a to the second. You subtract the exponents. And again, today what we're going to do is talk about why. So the first thing I want to do is I want to talk about this. I'm going to do the first one, and then y'all are going to do the second one, and then I'm going to call on people. So be prepared. Listen. So do you see how they've done this? 2 to the second means 2 times another 2, right? 2 to the third is 3 2's multiplied together. They're connected with multiplication. And with exponential notation, all you have to do to get the exponent is simply count how many things you have multiplied together times itself over and over, right? So there are how many 2's? 5 2's. So that's 5 factors of 2, or 2 to the fifth power. Yes? So let's do the second. What does 3 to the third mean? 3 times another 3. Times, then that's the multiplication in the middle. 3 to the first is just plain old 3, which gives you 3 to the what? Fourth power. Right? So, guys. Now, so all you need to do is remember that if you expanded it and then counted the exponents, that's how you would end up with the answer. So what I want you to do is I want you to do just what I did up here, but with a to the third times a to the fourth. Okay? Okay, so anytime you're multiplying with the same base, you can simply take those exponents and add them together. What about division? We have a to the fifth divided by a to the second. What does a to the fifth mean, Madeline? There you go. So 5 a's multiplied together. Sorry, I can't even write a 5. All right. And then Jessica, how about a to the second? Jessica's out. Yeah. Ava, how about a to the second? What does that mean? All right. So again, the rule for dividing them is to subtract them. Okay, who wants to move? So we're going to talk about what to do when you have an exponent on a bracket. I hate this rule, because it's a shortcut that only works on one type of problem. And then after that, it stops working. So if you're going to learn this rule, then you better make sure that you learn this rule and when to use it. Okay? I'm warning you that it is a disaster of a rule. Okay? Okay, so here's the rule. To raise a bracket to a power. Power is just another word for an exponent, right? Or an index. Yes? Now, if there is only one term inside, that's the key. If you have more than one term inside, then you cannot do this. Now remember, terms are separated from each other by pluses and minuses, right? So that means that if you see a plus or minus, you know that you have more than one term. All right? Now, so make sure you watch about what's inside, because that's the only time this shortcut works. Then what you're going to do is simply multiply every exponent on the inside by the, sorry, I'm running out of space, exponent on the outside. And again, I hate even showing you this trick, but you're going to see it a lot. But if you promise to be good, you can use it. Now, I'm going to show you how I would prefer you to do it. but they're going to give you some problems in here that would make it a nightmare to do it the right way, the way that everything will work. Okay? So remember, this is a shortcut, and shortcuts do not always work with every route you're going, right? Sometimes there's only one road to go, so you can't take a shortcut. Does that make sense? Is there a shortcut from here? Okay, can you to your desk, please? Sorry. I thought she canceled your appointment. Again, I hate to be like this, but I'm telling you, I've seen this ruin so many wonderful test papers on algebra students later in life because they want to use this shortcut every time they see this. If you have an exponent, so like say we have the 7 to the third raised to the second power, like the first one. Oh, sorry. Is it not writing? Thanks. I saw the right page in the... Okay, here we go. So this is the only case we can use the shortcut. Notice there is nothing added or subtracted in here. So what I mean by that is, what if I had a plus 7 to the second power? Notice there's some addition in there. That means that's more than one term. Now, if it's multiplication, it's all still one term, right? It's only when you see pluses and minuses separating. You can have a minus in there too, and that's all one term, right? That's just simply the sign of the 7. So it's just when it's one term. Now, if that is the case, then you can just take 7 to the 3 times 2, which gives you 7 to the 6th power. And it's nice and easy, but it only works in very special small cases. Now, what I'm going to tell you is that unless this number and this number are very big, so if you had like a to the 15 raised to the 3rd power, or raised to the, I'm sorry, too many brackets, raised to the 10th power, for example, that's a lot of stuff going on, right? And so then multiplying the 15 times the 10 makes a lot of sense, and you get a to the 150, right? You wouldn't want to write that out, okay? But if it's to the 2nd power or 3rd power or even the 4th power, it would really be better if you expanded it. And let me show you what I mean by that, instead of using this shortcut. Now, you can use the shortcut, but again, it's up to you to make sure you're using it right. If I was going to do 7 to the 3rd raised to the 2nd power, then I would just say, okay, that's a bracket raised to an exponent, right? So remember that the base of the exponent is the thing that it's touching. And so the base of the exponent is the entire bracket. So what that means to do is to take the entire bracket times itself, right? And 7 to the 3rd times 7 to the 3rd would be 7 to the 3 plus 3, or 7 to the 6. Don't multiply the 7s because they're the base. Remember, it's keep the base and add the exponent. So the temptation is to try to multiply the numbers. Don't. And usually when you're doing this, it's something like this with an exponent. So I have a to the 5th raised to the 3rd power. If I was going to expand that, it would be a to the 5th times a to the 5th times a to the 5th, which is a to the 5 plus 5 plus 5, or a to the 15th. And again, you don't have to show all this addition unless you're really, really just learning this now, okay? It doesn't hurt to show the addition, okay? It's better when you can, all right? Now, and again, the shortcut, because this is just a plain old a, is a to the 5 times 3, which is a to the 15th. It's shorter than writing that stuff out. I totally agree with you. But it's safer to write it out. Especially when you have something like this. Let me show you one. Let's say, sorry about that. I meant to keep the notebook paper. Let's say we have negative sending. Sorry. So be careful. If you do decide to use the shortcut, you have to remember that it's everything raised to the 2nd power. So not only the a was raised to the 2nd power, but the minus was raised to the 2nd power as well. So you had a negative times a negative. Okay? So do you see that it's a lot safer to expand it, even though it means you have to write more? Big deal, right? So, but if you know how to, if you're willing to remember that everything inside is squared, that's fine. So let's look at another example. Say, for example, we have negative 3a to the second, all raised to the third power. The temptation is just to take that 2 times the 3 and get negative 3a to the 6. But it's not correct. Because what this really means is negative 3a to the second times itself how many times? 3 times. And if you expand it, you can really see what it is you need to multiply out. You see it? So a negative times a negative is a positive, times another negative becomes a negative. Anytime you have an odd number of negatives multiplied together, it'll always give you a negative. If it's an even number of negatives, it'll always give you a positive, right? Remember, I think we've talked about that before. All right. If not, no big deal. Then I need to do the 3's. 3 times 3 is 9, times another 3 is 27. Now, if you were using the shortcut, that would be 3 to the second power, or to the third power, I'm sorry. You might not remember to raise that 3 to the third power, right? So you've got to be careful. Then finally, a squared times a squared is a to the 4, times another a squared is a to the 6, because we add them. Okay? Now, there was a lot of stuff going on, but it's a lot easier to see it if you expand them. Okay? Does that make sense? All right. So don't shortcut yourself into an issue, into a problem. It's a really bad shortcut. Now, it's there, and you can use it if you understand it. But if you have anything other than a plain old X or a plain old Y or something, I wouldn't. I would expand it all out and then multiply each piece. I'm just warning you about where this thing can go horribly wrong. Now, in the book problems that you're going to get, they're going to find problems where it works perfectly well, and then they're going to give you some where it absolutely does not work very well, just to make sure that you're really on your toes. Okay? So I'm not going to tell you not to use a shortcut if you know when you can use it, but if you don't, be careful. Right? So let's just look at some of these. So simplifying using the index laws. So these are just multiplying powers with like bases. So we're going to keep the base and do what to them? Add the exponents. Here we're just dividing powers with like bases. So we're going to keep the base and do what to the exponents? Subtract them. Here we have an exponent or a bracket raised to a power. If it's just something simple like 2 to the second, then all I need to do is take the exponents and multiply them, right? You don't have to expand it. But if you get something bigger, now all of these are easy. They're designed to show you the shortcut, right? Okay, and then they just mix them together here. And then down here, they have somewhere they want you to put in a number or an operation. So for example, 7 to the second raised to what power would give you 7 to the 6?
3.
Yeah, you just if you get it by multiplying, you can find the other one by dividing. So 6 divided by 2 gives you means that exponent would have to be a 3, right? A to the 5th with what operation would give you a to the 5th? With and a to the 5th would give you a to the 10th. Yeah, multiply, because in order to get that 10, that means you added those 2 5s. So sometimes they're going to be looking for an exponent or an index. Sometimes they're going to be looking for an operation. Here they're looking for 2 operations. Right? We want to end up with b to the 5th. So if we added 4 and 3, we would get 7 and subtracted a 2. So what should the operations be? Multiplication, then division. Division. Well, no, because then because remember, if you're plussing and minusing, if you're adding or subtracting, you just get more of them. So b to the 4th, well, actually, you couldn't even do it. Why can't I add or subtract these? They are not what? Like terms. Yeah. Because the exponents are different on them. Yeah? So you couldn't add or subtract them. But if you did, you just get more or less of them. So if it was b to the fourth plus b to the fourth minus b to the fourth, that would make 2b to the fourths minus 1b to the fourth, which gives you 1b to the fourth. So all of these are going to be either are going to be multiply or divide. Now it's adding or subtracting the exponents that you'll be working with. Okay, so be careful. All right, now, so you have some homework on page. It starts on page 132, 7a. So page 132, 7a, and you do all of them just to practice. This is such an important skill. You need lots and lots of practice. Okay?